new normal and anomaly sample for a system, normal sample to take the problem of living anomaly sample. Who don't know it is Xi'an is container marking level anomaly detection network capable of detect anomaly in any type of container marking. Experiment based on our proposal data set demonstrates the list of our network all the network proposed in this work provide a new insight into container marking anomaly detection. Thank you for listening.
Thank you. Thank you, Dr. Kang. I think we ask questions first before we give the certificate. So please stay on stage. Any questions from the audience? Please. 你可以用 Mandarin， 然后他用英文回可以。I can translate for you. 你问我，我帮你 translate. Please.
这个算是一个老的非一的问题，计算机系统的问题。
Do you consider this to be an old computer vision problem?
Yes. This is use a new method to 也算是但是它是应用在一个新场景，然后是用了其他领域，比如说网中网络这个方法，去应用到一个新的场景。
Maybe I do a little bit of translation because we have some foreign friends up there. So this is the answers that this is indeed an existing and probably old method, but it's applied in a new scenario in the container marking detection problem issue, right?
Second question. Large language model seems to evolve. This method detects our run of approach. 大语言模型现在和它的爱语要在这个方法里面要好吗？
我们是这个模型的话，是目前是用是一个比较简单的模型，但是我们后面目前工作也对。
So yeah, this application is in a very simple scenario.
We will enhance the network in the future.
Yeah. And any other questions from the audience? Yeah, please.
This is a non-academic question because I noticed that Mercy is the third largest container company, third famous, third largest. Do they have, if the method you developed, your company will use your method?
We are implying in a new station. 就是目前在一个试用阶段中是。
So we're still testing the software, the algorithm.
Is this study is there requirements for the request we want something mentioned to detect the missing marking signs on container? 这是公司的要求吗？需求吗？它是要
对，是一个合作，就是他们也是一个尝试性的一个工作。
After the detection of the missing marking signs, how do we deal with it?
They will find people to process the anomalies.
What kind of tools are using this kind of detection? Use camera, use photos.
Fix the camera to capture the images.
I actually have a follow-up question. That question has been secretly in my suppose that there will always be some kind of angle, not the front view. So how would you address that? You know what I mean? 你在现实的场景中，你比如说你开一辆高尔夫球场，整个港口围着转，那你这个镜头肯定不会每次都是刚刚面对着它，因为你看到那些影像全是吧？
我们这个目前应用在这个生产阶段，就是生产的时候，它在轨道上面是比较正的。
So the vehicle will be running on the rails. So which university or institution you came from? We are. No wonder you speak with some Cantonese accent. So any other questions? So if not, please join me to thank Dr. Pan. So we move on to our next speaker, Dr. Benjamin Scout.
Yes.
Is that how you pronounce it?
Bamrung Tausi School.
Tausi School.
Yeah,
okay,
yeah.
Okay. From Indonesia?
From Thailand.
From Thailand. Okay.
Thai.
Oh,
Yeah.
sorry.
Sorry.
So his topic is state estimation in power system under deterministic form standard injection attack by using minimization of nuclear form and L1 norm with noiseless constraint substitution. Dr.
Yes. Thank you very much for accepting this work as one of the papers to CIVEMSA. And my name is Bamrung Tausi School, the first author here. And this work was done with several colleagues at my department at Mahidol University in Thailand. I'm from Thailand. Well, this work is in the field of power system, and one of the tasks which is important to power system is state estimation. And in modern generation of power system, they are considering the fault data injection attack. And one of the technique is the minimization of the nuclear norm and L1 norm due to the sparse nature of the attack assumption. And the contribution in this work is that we substitute the constraint, we transform the constraint optimization in the classical problem to the unconstrained optimization problem. So the title of this work is quite long. It's state estimation in power system under deterministic false data injection attack. It's a kind of cybernetic attack in modern digital era. And the technique is using minimization of nuclear norm and L1 norm with noiseless constraint substitution. Okay, the content in this presentation is as follows. We are going to talk first about electric power system, and we will introduce you to measurements in electric power system, and we are going to consider state estimation in power system, and we move to false data injection attack, which is the main issue in this work. And we will review the previous idea about the minimization of nuclear norm and L1 norm with noiseless constraint. And we will consider our proposed optimization technique, which uses the constraint substitution. And we will see numerical simulation, and we will give conclusion to this work. Okay, let's have a look at the basic structure of a power system. You have power plant that generates electricity, and then you supply it with step-up transformer, and you have transmission line which belongs to transmission system, and you have power distribution system right here to distribute the electricity to household user. And of course, in operation of the power system, we're going to need to measure some basic quantities in the power system. For example, voltage, magnitude, current flow in terms of magnitude and injection. And we're going to need to know also active and power, reactive powers. And one of the important things is synchronized phasor, which is considered in this work. The phasor can be measured from phasor measurement unit, or PMU, which is well known in power system area. Well, the tools for measurement in power system can be multimeters, which is quite widespread in every laboratory. PQ data loggers. P means real power, right? And Q means reactive power in power system. We can also use oscilloscope to measure the signal, and disturbance analyzers, spectrum and harmonic analyzers, or PQ analyzers. Well, where the state estimation would locate? Okay, we have a transmission system for electric power system here, and there will be transmission line. Let's say it's transmission bus. And there are so many, but we are going to leave measurement device in some places in the transmission network. And all the results from the measurement will be collected at the data center, which is known as control center, which is known as control center. The control center will try to estimate the phase of the power system, the phase of the voltage, because we are in alternating current system, and there would be phase, right, because it's complex quantity. And at the control center, they will do also the load distribution, and we can do it by watching the monitor. One of the important things arises in the power system is that during the state estimation, there could be also some malicious data. For example, denial of service, replay, and false data injection. Like you may have ever seen the disruption of power system in Ukraine, which is a kind of false data injection attack. That can destroy the power transmission network in Ukraine. Well, let's move to the mathematical model. In typical state estimation, you get the received measurement quantity, which is denoted by Z. And you have H, which is the Jacobian matrix, which is a system property of the power system. And theta is the phase that we would like to know. And according to the measurement, there could be also some errors from the measurement devices or from the noise. And in modern network, there could be also this term, which is denoted by, which is known as attack. Okay, so the total quantity that we can observe is Y. So it's malicious data that includes also the attack. All right. In the attack side, we assume that the guy that is not good to us knows also the Jacobian matrix H. So there is a basis vector that span H to act as the attack to the traditional power system. So we need to find theta, but theta, when it's combined with vector B, is going to be theta 2, which is malicious data. We cannot, it's very hard to find theta, which is the state or the phase angle of the power system. Our target is to find theta. The traditional way is that they collect the data according to NT sample. So in discrete time framework, they collect the vector Y NT samples, and they try to separate the data, the desired data from the attack matrix. Okay, and they form up with the optimization from the rank objective function, and we assume that the attack has sparse property, which means some elements of the attack vector can be 0 or can be non-zero. But we don't know which element is 0 or non-zero. We assume that there should be some 0 inside matrix A. That's why we need to use a pseudo zero norm. But the rank function and the pseudo zero norm are non-convex function. They're gonna approximate this optimization problem as the nuclear norm. That's the title of this work. And L1 norm, which is a convex version for the pseudo zero norm. And they form up also the constraint. Okay, the received measurement is equal to the desired data and the attack, right? This problem becomes convex and can be solved by using traditional or typical software in many websites. Our work is that we are going to substitute the attack term in terms of received data and the desired component into the second term of the objective function. When we substitute this term into the L1 norm, the problem now becomes unconstrained. Okay, we don't have the constraint anymore. So in conclusion, in the previous work, the problem is convex. Our work is also convex. And in the previous work, the problem has a constraint. And in our problem, we don't have the constraint anymore. And the search dimension, in this problem, you can see that we need to search for matrix Z and matrix A, right? But in our work, we need to search only for matrix Z. So the search dimension for the previous work is 2 times M. M is the number of meters that's located in the power system. NT is the number of samples. But in our work, we need to search for only Z. That's why the search dimension is reduced by double, by only half of that. Okay, so let's have a look at the numerical simulation. The error of the theta, which is the state vector that we would like to know, this is the area of that state vector. And the error from previous technique and our technique remains the same. Okay, you can see that the plot are nearly the same everywhere according to several value of signal to noise ratio. And regarding the root mean square error, so bias is the first order error observation. Root mean square is the second order error observation. Okay, so you can see that the error behavior is the same for both techniques. And regarding the standard deviation mean, it means the deviation from the mean for each method. Also have the same performance here. But the difference is the time for computation. This is the former technique. Okay, you can see that the time is quite high. And this is the time for computation in our technique when we don't have any constraint anymore. So the contribution of this work is only to reduce the computational time. You can obviously see the reduced time for computation. And another aspect is that we use less memory during the computation. So the conclusion of this work is that we propose an optimization technique to extract the attack-free signal component from the attack data, and all is taken from the measurement in the power system. Numerical results indicated that this technique takes less computational time than the previous work. And that's all for my presentation. Thank you very much. Xidian.
So thank you, Dr. Cao.
Yes, you can say that.
So any questions from the audience? Any? Yeah, please, Dr. Zhang.
Because the power system is very, it's really safeguard. So I know, I noticed that a lot of simulation data, you have a real data, or received a time from reality?
The raw data is not included in this work actually. We just take the Jacobian matrix from an exercise in the book, which is published. In the future, if the conference can accept the extended version of this work in the transaction format, we're gonna use the IEEE 39 bus standard, the structure of power system that has 39 buses, and that would be close to the real data or not, I'm not sure. Or we are going to set up the experiment from the measurement table in our laboratory to generate the actual state vector and also the actual Jacobian matrix. So.
Any other questions? Please. You can say in Chinese if you want. I'll help you translate.
可是我合并给你传一张中文，不然。
也可以，it's okay, either way.
This is information safety question. Our nice now CS question. 这是一个
Sorry again.
So what you're asking is the problem that you're presenting, is that a information security issue?
Yeah, false data attack can be in many forms. If you take a look at this one, like denial of service, it means someone tried to reject the call to the power system, which is not the truth. Okay, someone tried to destroy the whole power system, like that took place in Ukraine, that makes the whole country without the electricity. That's one of the attack system that might be your question. And there is another type of attack, for example, replay. And for my work, I consider false data injection, which is this term that can happen. Someone try to add some value to this network. They try to destroy or disturb our system, so our operation cannot work perfectly with them. There are many works, some of them try to get rid of the attack. But for my work, I don't get rid of the attack, I don't remove, but I try to estimate or find the vector theta even someone try to attack the system. Yeah.
information security 的问题，就是它这个电网里面的话，有人可能会去扰动它的搞一些假的信号去扰动这个网络。如果 understand correctly， 那么它搞这套方程应该是又去检测这个看看有没有这些信号。
Because in modern technology, everything is controlled in digital form, right? Someone can hack the system and they try to insert the wrong data, the false data, to any line in this network structure. So for us at the control center, we will suffer from that disturbance. Yeah, that's the vector A here.
对，所以它这个网络这个电网可能会受到这些攻击，那么它又这套方程的话，就是想要去检测这些有没有攻击的信号。
Okay.
Okay, so thank you very much, Dr. Zhao.
Thank you.
I have a certificate for you.
Thank you.
Please stay on stage. You flew all the way from Thailand?
Yes, yeah.
You landed today?
Yeah, yeah.
Look at me. 3, 2, 1.
Thank you. Thank you.
This is yours.
Thank you.
Thank you.
Chinese people visit Thailand, but you visit us.
Yeah. I get much impression about your product like EV car, and this is one of my motivation
Okay.
to visit China
How many days are you stay here?
until 17.
17?
Yeah,
Okay.
17.
Yeah, have
Yeah.
a good time.
Yeah, I
Okay.
hope so. Thank you.
Our next speaker is Dr. Tian. His topic is ORC and assembling deep learning framework